When writing a program, you'll find that you'll often need to repeat a series of statements over and over again. So let's go ahead and write a program that shows how to do this in action. So I'm going to start off writing a program that works a single time. Let's write a program that asks the user for a bill at a restaurant and a tip rate that they want to leave on that bill. And then we'll compute how much of a tip we should leave at a table. So if we want to do this without repetition, just doing it one time, we need to do two things. First thing is get the user input to compute our tip. So what do we need to know? Well, we need to know the total bill. Actually, we'll just call that bill. And we're going to set that equal to the float of input of enter total bill. And then the other piece of information we need is the rate. And the rate is the percentage that we want to leave on the table. So enter tip rate. So we've got those two things. Once we have those two things, we can go ahead and compute the tip. So compute tip. So the tip is going to be equal to the bill multiplied by the rate. If the bill is $100 and the rate is 15%, multiply those two together and the tip will be how much we should leave on the table. And finally, we can output result. So I can go ahead and print out your tip to leave will be the tip. Pretty easy, and that is a sequence structure that allows us to go through and do these three things in linear order, ask the user for some input, compute the tip, and then output the result. Great for one time, but what if we want to do this 2 times, or 3 times, or 4 times, or 1,000 times? This is going to be a difficult problem. So one thing we can do, given our current tool set, is to copy and paste this. I can go over here and I can copy this. And once I've copied it, I can go down and paste it, and I can paste it, and ta-da, our program is going to run for 3 users. But this is a very, very unmanageable way to write a program. If you find yourself copying and pasting over and over again, there's probably a better way to program. So we're gonna explore some ways that we can make this more efficient. But if you look at this, yeah, this will work for 3 users. The big problem here, though, is that our code is going to become unmanageably long. If I was to do this 500 times, I'd have to copy and paste that block 500 times over and over and over again on my source code, and my program is going to become incredibly long. Another real big problem with this is the fact that if I ever need to make a change to any one of those blocks, I need to change it everywhere inside of my program. So from a sustainability perspective, this is going to make my code very, very difficult to maintain in the long run. So we're not going to do this. What we are going to do is we're going to explore a construct in programming languages called a loop. So a loop is a structure that allows us to repeat a series of other statements a number of times. So in order to do this, I'm just going to go ahead and comment out the code we just wrote, because we're going to come back to this in a little bit. And we're going to explore one type of loop called the while loop. So a while loop is called a condition-controlled loop. And it works kind of like an if statement. So you remember if statements? If I say x is equal to 5, if x is greater than 0, print hi. We know that with an if statement, first thing we do is we ask a question, and the question is expressed as a Boolean expression. So we say, well, if this expression evaluates to true, we go ahead and perform the statements that are indented underneath the if statement. And if that expression evaluates to false, then we skip these statements and we keep going with our program. A while loop works in almost the exact same way. In fact, all I need to do is just change that if into a while, and this will work. The way to read this, though, is that with an if statement, we say evaluate the expression. If it's true, do that, and then keep going and hit the statement directly after the if statement indented to the left. If this statement evaluates to false, we skip this statement and we go down here and we run the print statement as normal. If I switch this to a while loop, though, things change a little bit. With a while loop, what I do is I say, well, I'm going to evaluate the statement. If it's true, I'm going to do what's inside of here, but then instead of jumping down and executing this line here, what I'm going to do is I'm going to say, no, I just printed this. I'm going to come back up and I'm going to reevaluate that statement. I'm going to ask that question a second time. And if the answer to that question is true, then I go ahead and I perform this statement again. And then I come back up and I ask the question again. And if the question is true, I perform that statement, and so on and so on and so on. So you can see here that if I was to ask you how many times this statement would execute, you'd probably say an infinite number of times, because the value of x does not change in this case. So this is what we would actually call an infinite loop. And if I was to run this program, you'll actually see over there on the left, it's going to say hi, 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 hi over and over and over again because the value of x is actually never changing in this program. So whenever you get caught in an infinite loop, you can just hit Control and C on your keyboard, and that will cause the infinite loop to stop executing. And we want to try to avoid working with infinite loops. We'll talk about some situational uses for them later in this lecture, as well as in future classes. So let's go ahead and see if we can design a program using this idea of a while loop. So let's take this idea of our tip calculator and see if we can write it using a while loop. So the first thing we always have to do with a while loop is we have to go ahead and we have to set up some sort of variable that's going to control the while loop. So we call this a control variable, and this variable always gets created outside of the loop. So that's the first thing we do. So let's go ahead and set up a variable here. And I'm going to set up this variable, and this control variable, this is going to keep track of whether, we should loop or not. So I'm going to say keep looping is equal to yes. Just the string yes is going to be stored in the variable keep looping. Now we enter our while loop. So our loop here is going to say, well, as long as the variable keep looping is holding the value yes, then what do I want to do? Well, the first thing I want to do inside that loop is I want to basically do this block down here. So I'm going to paste this block over here, and then I want to put those statements inside the while loop. I can highlight all of those statements and hit the tab key on my keyboard to indent them under the while loop right there. So let's go ahead and trace this. Program starts, set up a variable called keep looping, and now we're going to ask the question, is the keep looping variable holding the value yes? It is the first time. And then what do? We ask the user for a bill and a rate, we compute their tip, and we print their result. Let's see how it works. I'm going to run this program, and over here on the left, enter total bill, $100, enter tip rate, 15%, and the tip to leave is 15, and notice what happened. We came back and we started asking the user a question again. We started asking them for the total bill again. That's awesome. So now I'm going to say $200 at a 20%, and great, it computed 20% on 200, and it asked me for the total bill again. Well, what if I wanted to stop this program? There's really no way for me to stop it. I can't execute it I can't end it gracefully. What I could do is I could hit Control C over here to force the program to crash. That's really not the best way to do it, but we can design our program so that we can actually control when this loop ends. So let's go ahead and take a look. Step 1, set up our control variable. Step 2, determine whether that control variable is holding a known value. If it is holding a known value, then go ahead and actually execute the logic for our program. And then when we're all done, let's go ahead and ask the user if they want to loop again. So I'm going to say keep looping, the variable keep looping, is equal to input of would you like to go again? Now let's go ahead and trace this program. Keep looping is initially holding the value yes. The first time we come here, is the variable keep looping holding the value yes? True. Go ahead and get the bill, get the rate, compute the tip, print out the result, and now overwrite the value of keep looping with the answer to the question, what would you like to go again? If the user enters the word no here, when we come back around to the top of the loop and we ask the question again, is the value no equal to the value yes? Well, in that case it isn't, so the loop is going to cease executing at that point. So by changing the value of a variable within the loop, we can actually adjust how the Boolean expression is going to evaluate at the top of the while loop, and we can prevent the loop from re-executing a second time.